Test hypotheses about a population mean. Our objective, do we want to test hypotheses about a population mean? Well, we finished up working with population proportions, and now we're going to work with population means. Let's remind ourselves what we know. If 1, a population has a normal distribution, or 2, the sample size is large, greater than or equal to 30, then the sampling distribution of x bar, the sample mean, is approximately normal, with mu sub x bar equal to mu, and the standard deviation sigma sub x bar equal to sigma divided by the square root of n. Let's talk about our steps for testing about a population mean mu, and they're going to look awfully familiar to how we did it about a population proportion p. First off, conditions above are satisfied. A bit easier to satisfy conditions for a population mean, one or the other. Determine the null and the alternative hypotheses. In this case, as a reminder, your null hypothesis is always a statement of equality. So we're using the population mean this time, and a two-tailed test is not equal to a left-tailed test. Your alternative hypothesis is less than, arrow pointing to the left. A right-tailed test, your null hypothesis is greater than, your arrow pointing to the right. Mu sub 0 is the assumed value of the population mean mu determined by the problem. Okay, as we did before, determine the level of significance. Let me make sure my paper's straight. Alpha, which depends on the seriousness of making a type 1 error. As a reminder, a type 1 error is when we reject the null hypothesis, when in fact the null hypothesis is true. You'll be given the level of significance in the problem. 4, we're going to use StatCrunch to come up with that p-value, and we're going to use stat t-stats 1 sample, and it will be with data. If you have raw data, it'll be with summary if the data are already summarized. And then we're back. Is it unusual? Well, if it's unusual, it's when the p-value is less than alpha, your level of significance. Alpha is the level of significance. Then we're going to reject the null hypothesis. As a reminder, our little phrase, if the p-value is low, the null must go. We reject it. Okay, turn my paper over. Get ourselves back started here. And then we're going to state the conclusion in the words of the problem. Reject the null. We will say with a alpha level of significance, there is enough evidence that the alternative hypothesis is true. But we'll use the words of the problem. If we fail to reject the null, we'll say with an alpha level of significance, there is not enough sufficient evidence that the alternative hypothesis is true. Again, using the words of the problem. Note, for small samples, if the data have outliers or there's extreme skewness, the procedure should not be used. Okay, generally, if the sample is small, we're going to be told that the QQ plot / normality probability plot looks good and the box plot shows no outliers. We've checked that in the past. We've gone to the QQ plot and we've compared that number to the requirements in our chart. And we've also gone to the box plot looking for outliers. We'll generally be told that things are probably just fine. Otherwise, we'll have to go there. Okay, we'll do 2 examples, a large sample example and a small sample example. Example 1, assuming the resting metabolic rate, RMR, of healthy males in complete silence is 5,710 kilojoules per day. Researchers measured the RMR of 45 healthy males who were listening to calm classical music and found that their mean RMR was 5708.07 with a standard deviation of 992.05. At the alpha equals 0.05 level of significance, is there evidence to conclude that the mean RMR of males listening to calm classical music is different from complete silence, which was 5710 kilojoules per day? Okay, next part one, our conditions. Well, we have 45 healthy males, so our sample size is 45. That is greater than or equal to 30, so we're good. We were not told that it was normal, but we have an either-or situation. The sample size is large enough. We don't need to be told whether or not it's normal. We can assume normality thanks to the sample size. Step two, let's put down our null hypothesis and our alternative hypothesis. Our null, we're dealing with mean. Let's see here. There's our word mean. So our mu is equal to 5, 7, 10. Our alternative hypothesis is different from means not equal to. Different from can be greater than or less than. So it's going to be different from 5710. Step three, what is our level of significance? Well, we're told at the 0.05 level of significance. Okay, step four, let's just note that our sample mean is 5708.07. Our sample standard deviation is 99205, and our sample size is 45 males. Okay, and let's come out of that. So we need to know that information to go into T-stats, if I'm not mistaken. So let's go into our calculator. And I'm seeing a screen that is not, there we go. Let's go into stat. Not calculators, T-stats right here. Okay, we're doing one sample. The data is already summarized, so with summary, and we need to put in the mean, the standard deviation, and the sample size, which is why I noted them. The mean was 5708.07. Our standard deviation was 992.05, and our sample size was 45. We're going to perform a hypothesis test for mu, our population mean. Well, our population mean was 5710. And for our null hypothesis, our alternative hypothesis is not equal to, which it defaults to. So we can go into here to press compute. And here we have it. Okay, here's our sample mean, 5708. We knew that, we put it in there. And here's our p-value, 0.9896. That p-value is huge. We are not going to reject the null. That is a massive p-value. And while we're here, let's note the t-stats, because some of your MyLab problems may have you enter the t-stat from the t-chart. We're not going to make use of that, but you may need that for your homework. So negative 0.013 is our t-stat. Okay, to 3 decimal places. So let's go back to here. Okay, so from StatCrunch, we came up with a p-value equal to 0.9896. Let me quick check that. Yep. And I just want to note that t-stat, which you might see as t sub 0, was equal to negative 0.013. You may need that in your homework, although we're not making any use of that. We're letting StatCrunch handle this for us. Okay, so 5, is it unusual? okay, is 9896, remember, is our p-value less than alpha? Okay, is this true? And the answer is a very definitive no. It's way too big. If the p-value is low, the null must go, and that is not the case. This p-value is high. So the null will fly. How about that for a silly thing? Okay. With a 0.05 level, we're going to be stating our conclusion here. Level of significance. There is not enough evidence. Remember, we're talking about, we're stating our conclusion for the alternative. There's not enough evidence that this is true, okay? There's not enough evidence that the mean RMR of males listening to calm classical music is different from 5710 kilojoules per day. There you have it. Okay, a recap here. Checked our condition. We didn't have to worry about whether or not we were told that it is normal because our sample size was large enough. Our null hypothesis and our alternative hypothesis, our significance level. We needed some data for StatCrunch and the T-stats calculator. The mean we were told, the standard deviation we were told, and the sample size we were told. We got a huge p-value. We noted the t-stat, which is also t sub 0, because your homework might have you put that in there. Is this unusual? Well, unusual means p-value less than level of significance. This p-value is way larger than level of significance, so it is not unusual. So we would conclude with a 0.05 level of significance. There is not enough evidence that the mean RMR of males listening to calm classical music is different from 5,710 kilojoules per day. Okay, let's take a look at a small sample, okay, in which we're given the data. And let me get my, give me a second here to, yes, get myself organized on this side. Okay, I think I'm organized. Okay, let's take a look at another example with a small sample size. All right, according to the U.S. Mint, quarters weigh 5.67 grams. A researcher is interested in determining whether the state quarters have a weight that is greater than 5.67 grams. He randomly selects 18 state quarters, weighs them, and obtains the following data. Here are the weights to the nearest 100th of a gram for the 18 quarters. At the alpha equals 0.05 level of significance, is there evidence to conclude that state quarters have a weight greater than 5.67 grams? Okay, so check our conditions. Okay, well, first off, 18 is less than 30. So the sample size is not large enough. We're also not told population distribution is normal. So these two things are X's. One of those two things has to be true. So what do? We go into our normal probability plot, also known as the QQ plot. We then check our box plot to see if we can move forward and assume normality. So I'm going to write here, we check QQ plot and box plot, and all looks okay. Okay, so we didn't meet these two conditions, but we checked the QQ plot for linearity, we checked the box plot for outliers, and we were fine. So we're going to assume some normality here. Okay, number 2, our null hypothesis is our mean. Let's see here. Yes, I guess we did. Yeah, okay. Our mean is equal to 5.67. Sorry about the pause there. Our alternative hypothesis, he wants to be greater than 5.67 grams. Okay, our level of significance alpha is a 0.05 level of significance. And number 4, let's go to StatCrunch. Okay, now, you're going to need to put this data. If this data is not in StatCrunch, you need to put it into StatCrunch. I've already done that. We'll make a note here. StatCrunch is going to calculate all of this for us. Okay, but I'll make a note. I mean, we don't need this information if the data is raw, but I'll make a note here that I went into StatCrunch and I put this data in, and I had it do a summary stat, mean, standard deviation, and sample size. We know the sample size is 18, and my mean came out to be 5.702, and the standard deviation was 0.50. Okay, so let's go into here and you'll see what I'm talking about. Okay, so here is the data put in, and here are the 18 weights of the quarters to the nearest hundredth of a gram. We're going to go into stat, and I'm going to close it. We're going to go into t-stats, one sample. We have the data. It's not summarized. We have the data. I'm going to choose with data. Okay, now notice it's going to do it for us. When the data is there raw, it'll calculate and it'll take care of the mean and the standard deviation for us. We just need to select the column, okay? And then we just need to perform the hypothesis test. Okay, so our mu, remember our null hypothesis, our null hypothesis is always one of equality, and we have 5.67. Okay, in this case, it defaults to the not equals to. Well, we want to be greater than, so I'm going to choose greater than, and it automatically fills in 5.67. Okay, now we can compute. Now notice what it did. It gives us the mean. I already calculated that for us. Okay, but it gave us the mean, which I already had. And as you'll notice here, here's our p-value, 0.0068. And also make note of your t-stat. Again, sometimes the homework will ask you for the t-stat, which is known as t sub 0, in order to complete the problem. So make note of your t-stat, which we'll do in just a minute. There's our p-value. Okay, if the p-value is low, the null must go. 0.0068 is pretty low. Let's take a look at our problem. Okay, so back to here. Step 5. Oops, I can get to step 5. StatCrunch told us we have a p-value equal to 0.0068, and we're just going to note our t-stat, also known as t sub 0, was equal to 3 decimal places, 2753. Okay, 5, is this unusual? Okay, 0.0. I missed a 0. I bet you all caught that out there. Coleman, you missed a 0. 0.0 is less than our alpha, our level of significance, 0.05. So So yes, this is unusual, okay? If the p-value is low, the null must go. We're rejecting the null, okay? So 6, okay, at the 0.05 level of significance. Okay, there is enough evidence to conclude that state quarters have a weight greater than 5.67 grams. Okay, let's recap this one. Started off with our, can we assume some normality? The sample size was small. We were not told that the population distribution is normal. So then we had to go and check our normal probability plot, also called our QQ plot and our box plot. We did that. I'm saying we did that, and all looked good. We can move forward. We have our null hypothesis, which is always a statement of equality. Our alternative hypothesis is greater than, so our mean is greater than 5.67. Our level of significance is 0.05. We went into StatCrunch. Okay, our data was raw, so we had to put our data into StatCrunch. It will calculate this stuff for us. I did that using summary stats. Once the data goes in there, I went to t-stats. I came up with a p-value of 0.0068. And we noted the t-stat, which is t sub 0 for the t-chart, was 2753. Not important for us because we're using StatCrunch, but it may show up on your homework. Unusual means the p-value is less than the level of significance. It is less than, so yes, this is unusual. When it's unusual, the null must go. We reject the null. So at the 0.05 level of significance, we're rejecting the null. There is enough evidence to conclude that the alternative is true, that state quarters have a weight greater than 5.67 grams.